Okay, so we're going to look at position and average velocity. We've done this before, okay, but we haven't actually used these terms. So everything that we're going to do with this one, it's actually an application of what we've done before. So those people who are doing physics, you would have done some of this in Year 10, but the people who are doing, how many people are doing physics? So a couple. Okay, those people who are doing physics are going to be very familiar with these terms and these applications, okay? But it doesn't mean to sit back and do nothing.
No one would do that in this class.
So in physics they often use the terms of displacement, okay? But in maths they tend to use the term position, okay? Why they change the terms? Just to be painful, okay? Yeah, we've been doing chapter 7, we've done 16, we missed out E. We've done 17, we're coming back and finishing off this one now. So it can be positive or negative. So position actually has a direction to it, okay? Rather than, if we were just saying what the distance it travels, or the distance from a point, it's quite different to its actual position, okay? So a positive direction will be specified on these questions, okay? So you'll have a positive direction or a negative direction, or it'll have a graph that shows you. So if the graph goes into negative, it means it's gone past the point. So if we have our point here, this is our starting point, and if I call that the positive direction, and then this would be its negative direction. Okay, so this might go that way, turn around and come back this way. But if I've said that's a positive direction, then we've got, it can be actually over here, which is saying it's in a negative direction to its start from where it started. Okay? So position has either a positive or a negative. It means that it's come past its original point and gone backwards. If it can be vertical as well, so depending on the different sorts of questions, but it'll have a position of, it'll be obvious whether it's negative or positive, okay? But just to keep that in mind. So if I asked you, if this went to, say, 4 metres in this direction and 4 metres in this direction, its location, okay, or its position, if it stops here, so this is its stop, so can you see that if this is where it stopped, it went there, it's negative 4 metres from its starting point. Can people see that?
Yeah.
Yeah? Because it's over here. If this is its starting point, and this is at 4 metres, that's at 4 metres, it's gone negative over this side. But the total distance is going to be 4 plus 4 plus 4 is going to be 12 metres. So the total distance is 12 metres, but its position is -4. Does that make sense?
So the position is where it stops.
The position is where it is from its starting point, or a specific point.
Okay.
Yeah? Does that make sense? So, I don't know if you want to copy that down under there or not. I'll give you some time to do that if you want to. So, if we've got a rate of change, what does that mean in the terms of graphs or or other things. It's the gradient. Okay? So, the velocity is the gradient of a position time graph. Or, then we've got so what if we were trying to find the instantaneous velocity?
Same way you tried to find the instantaneous gradient.
Instantaneous gradient. Yep. So it's the which is, what do we call that?
Tangent.
Yep. Which is a tangent, which is the derivative. Okay, when we're starting to get the derivative, it tends to put it in the word, instead of like f of x, becomes s. So we've got s normally means speed, but s in this term is displacement. So we would have s of t, so the derivative, so that's a position up with s dash of t or ds dt for our derivative. So we're used to working with f of x's, f dash of x, dy dx. This time we're changing that to s and t instead of x and y. So you'll see this notation there. We want to find the average velocity between 0 equals 2, between 0 and 2 seconds. What might be the first thing I do? Yep. So, I want to find the average velocity, so I want to find the gradient. So I need my x1, y1, x2, y2 in that sense. So, s of 0 equals, I will work that out, s of 2 equals,
S of 0 is 4.
S of 0 is 4. Yep. So 2 Yep. That's 8. Okay. So this becomes my y1. My y2, this is my x1, x2, if we're looking at our concept of gradient. So my average velocity would be 8 minus 4 over 2 minus 0. We haven't been told what it is, so if we have meters, we have seconds and we would put meters per second. Haven't been told what that is.
But with the derivative form.
Yeah. It says here, our instantaneous velocity is our instantaneous gradient, which is our tangent or derivative. We've got it here. We've got s of t, so we just need to find s dash of t. So the derivative of that, which will be
4 take 2t.
Yep. Now what would I do?
Sub
Sub in 3. So remember, velocity velocity can be negative. Okay, so that means that t equals 3 will have a negative gradient. Okay, so what have we got for this one? So our gradient. So our rise over run or minus our points, and you should have got 4 take 2 over 1 take 0. And what do we know about this? It's negative. So it's a negative gradient, so you should have got negative 2. And we've got our units. Because we've got units on our axis, we need to make sure we've got our units. So don't forget your units. Yep. So what's between 1 and 2?
0.
0. Okay. 0. Okay, it's flat, horizontal. So what's the particle doing? It's a gradient 0. Okay.
Constant wire.
It's like a constant, like oh.
What is it, Hugh?
Stationary.
Stationary. It's not moving. Its position is not changing. The time's moving along, but the position is not moving. Yeah? So, at 1 second, I'm here. At 1.1 second, I'm still here. At 1.2 seconds, I'm still here. 1.3, at 2 seconds, I'm still in the same spot. Then I start moving. Does that make sense? It's the time that's going along. Well, sorry, hours. So I've stopped here for an hour, not seconds. So I might be having a cup of tea or something like that. So what's the velocity between 2 and 3? So we found the gradient, and you should have got that to be 1. And it's positive. So 1 kilometre per hour. Okay? What about the last bit? Negative 3. So that negative is saying that I'm returning back to my starting point. My starting point was here. On these graphs, this is my starting point. I started 4 metres away from it. Okay? So I've started 4 metres away. I've walked this far, got to there. Obviously it's walking at that pace. It's no jet plane, that's for sure. I've stopped, gone back that way. Okay. If we have a look at this one here, at this graph here, can anyone tell me some information about it? If this is a particle,
It goes up in seconds.
okay?
It's in meters per second.
It's in metres per second, okay? So it's in metres per second.
And then it's going out to a point, slowing down, stopping and coming back.
So it's going out, stopping, so it's gone out to a point, it's stopping and then coming back. What other information? Can we add any values to this? How far out did it go?
25 metres.
So it went out 25 metres. Where did it stop?
You give 3 seconds.
3 seconds.
Stopped at 3 seconds. How long did it take to come back?
3 seconds.
3 seconds.
Any other information that we could get from that? How do we know that it stopped?
Gradient zeros.
Yeah. Because the gradient is 0. Any other information that we can get from it? I'm trying to get this so that you get to understand the graphs, because you'll be given graphs and you have to understand all the different information that you can get from a graph. Okay? Because you're going to get different questions from that graph. So instead of me asking you the questions and putting them down like these ones, I'm asking you to tell me what information that you can see. What other information?
It goes 50 meters in 6 seconds.
Yep.
It's turning point at 3 times.
Yep. So turning point and so I've got a turning point at 3:25.